We're going to talk about solving trig equations here. And so what we're going to be doing is using our trig identities that we've learned and applying some of those to these equations. So in the first example here, we've got 2 cosine squared x plus 2 cosine x equals 0. And so what I think would be probably a good thing to remind you of is just think of cosine x here. Just think of it kind of like you would a variable in any equation. And so we're going to, I'll show you kind of a trick after we solve this that might help clarify things a little bit, but let's solve it first, then I'll show you what I'm talking about. So what I can do, since this equals 0, is I want to get everything factored on the left side. And so what I notice is there's a cosine in both terms, so I can factor out a cosine x. Think of this as like undistributing. So we've got 2 times cosine x plus square root of 2. So we distributed out a cosine x, or factored out a cosine x, and then what's left over is 2 cosine x plus root 2. And that still equals 0. And then one thing we've learned is called the zero product property, is if you have 2 things that are multiplied together, in this case cosine x and that stuff in the parentheses, when that equals 0 when you multiply, that means that one of these 2 things has to equal 0. That's the only way that it's going to work, because if you have 0 times anything, it equals 0. It's the only way you're going to get 0. So we're going to do cosine x equals 0, and then we're also going to do 2 cosine x plus root 2 equals 0. So we set each part equal to 0, and those will be the 2 possibilities of where this will be true. So the first one is already done for us. Cosine x equals 0. We don't have to go any further than that. The next one, we have to subtract square root of 2 first. Then we've got 2 cosine x equals negative root 2. And then we divide by 2. And we get cosine x equals negative root 2 over 2. So those are our 2 answers. Now, I told you earlier I was going to show you a little trick here. Sometimes what you'll see is people replace cosine x. So they'll say, let cosine x equal some letter. Oftentimes they'll use the letter u. And so what they'll do then is they will rewrite this equation as 2u squared plus square root of 2 times u equals 0. And then they'll solve it for u, and then at the end what they'll do is replace the u with cosine, and they will get the exact same answers. So that's a pretty cool technique to use if you don't want to get all confused with the cosines or the signs in a different problem or whatever. You can replace that trig identity with a letter, typically u, and then solve it and then switch it back at the end. It's the same thing, just maybe a little bit less confusing. Maybe more confusing. Who knows? Okay, so let's think about a unit circle here. Let's find our answers for x, because we want to solve for x, not just for cosine of x. And so there's our unit circle. And this first one, I'll call that A. This first one says, when is the cosine of x equal to 0? Well, the cosine on the unit circle is the x value. And so when is the cosine equal to 0? Well, that's going to be at 90 and at 270. So 90 and 270. Well, what about when is the cosine of x? We'll say b here. When is the cosine of x equal to negative root 2 over 2? Well, that would be right here and right here. That's at 135 and at 225 degrees. So if they're asking us to give our answers in degrees, we're going to say 90, 135, 225, and 270. If they ask us for the answer in radians, 90 is pi over 2. 135 is 3 pi over 4. 225 is 5 pi over 4. And 270 is 3 pi over 2. So you just convert it to radians, and you've got your answer. Now, if it asks for the answers for all real values, and what we're going to do, scroll up a little bit here, is for like the 90 and 270, oops, this is not cooperating, sorry. Try that again, there we go. Treat it just right. Okay, so for the 90 and 270, those are exactly 180 degrees apart. So you go from 90 to 270, that's 180, and then back again is 180, so those are exactly 180 apart. So you would write 90 degrees plus 180n. And that just means you put a whole number in for n or an integer in for n, and you'll get all of the possible ways. So every time you rotate around the circle, let's say you rotate it around twice, that would be 720 degrees. And then you just go another 90, and you've got your answer. All right, so if we wanted to write this in radians, we would do pi over 2 plus pi n. All depends on what you're asked in terms of how to write the answers. Now, for 135 and 225, it's not quite as easy because they're not that 180 apart. They're 90 apart, but they're also 270 apart depending on which way you're going. So we can't write those two with one expression. We have to write two different expressions. So it'll be 135 plus 360n. If you wrote it in radians, you would write 3 pi over 4 plus 2 pi n. And then if we, for the 225, we do 225 plus 360n. And in radians, that'd be 5 pi over 4 plus 2 pi n. Okay, so those are the three different ways to write the answers. It all depends on what you're asked. If you're asked give the answers in degrees, then your answer is going to look like the degrees. If it says give the answer in radians, then it'll be like the radians and all real numbers. In degrees, we have that, and in radians, we also have that. All right, so there's the first example. We're going to go through two more, and we'll do kind of the same idea on both of these. So here is example number 2. If you want to try this one on your own and see if you can get it, that'd be pretty sweet. If you don't think you can do it, then just keep watching. So the first thing we're going to do is, if you notice, this is cosine and this is sine. Those are not like the first one where it was both in terms of cosine. Now we have two different trig identities. You cannot solve these if you have different trig identities. So we have to think, can we change cosine squared x into sine, and can we change sine x into cosine? We want to get them both to be the same trig function somehow. So what I'm going to do is I'm going to look at my toolbox of trig identities, and I'm going to look for something where I can change either cosine squared x into something with sine, or can I change sine x into something with cosine? And if you see right here, cosine squared theta is 1 minus sine squared theta. So what I can do is I can replace the cosine squared x with 1 minus sine squared x. So we've got negative 1 minus sine squared x is what that cosine squared x turns into. And then plus sine x equals 1. We distribute this negative, and we get negative 1 plus, sine squared x plus sine x equals 1. Now, on this one, you remember we can think of, you could think of sine x as u. So I think that's what I'm going to do here, is I'm going to replace it. I know I didn't do it on the first one. You don't have to do this u substitution. It's just going to make things a little bit easier, I think. So -1 plus u squared plus u equals 1. So we have a quadratic here. I know it's a quadratic because we have u squared. And so whenever you have a quadratic, you always have to get everything to one side and then factor, or quadratic formula, or whatever method you choose to use. So to do that, I'm going to subtract 1 from both sides, and then I'm going to write it in standard form. And what I mean by that is I'm going to write the biggest exponent first, so u squared plus u minus 2 equals 0. Now I'm going to factor this. And if you don't like the substitution thing, you can leave it all as signs. You could just have sine squared plus sine minus 2 equals 0. If that isn't confusing to you, then that's totally fine. So this thing is factorable, I think. We know u times u is u squared. And then it has to multiply to -2, but add to 1. So it's going to be u plus 2, u minus 1. So then we have u plus 2 equals 0, and u minus 1 equals 0. This would be u equals -2, and the other one would be u equals 1. So then this is sine of x equals -2. And this is sine of x equals 1. So all I did was I just said that sine of x is u, and then I switched it back at the end. Okay, so once again, let's go look at our unit circle. I'll sketch a unit circle over here. And we need to figure out, where do these answers happen? So let's start with the first one. I'll call that A. When is the y value, sine is the y value on the unit circle, when is the y value -2? So the answer is never, right? The biggest, the hypotenuse, or the radius on the unit circle is 1. You can't have the y value be -2. So this kind of gives us a dead end. We don't get any answers from that one. And that's okay. That's going to happen here sometimes. The other question is, when is the y value equal to 1? Well, it's right there. That's when y is 1. That's at 90 degrees. So our answers for degrees is 90. For radians, it's going to be pi over 2. And for all real values, it's going to be 90 plus 360n. Or you could say pi over 2 plus 2 pi n. So this one only resulted in one possible answer. We only got one possible answer because the other one was kind of a dead end. Okay, so there's example 2. Let's look at the third and final example here. We have tangent squared x plus secant x equals 1 this time. So same idea as last time. We are going to look at our toolbox, and can I change tangent squared x or secant x into one of the other ones? And if you notice here, we've got tangent squared theta equals secant squared theta minus 1. So let's go back, and we're going to replace tangent squared x with secant squared x minus 1. So plus secant x equals 1. So this one, you're going to see here shortly, it's going to be almost the same question as before. So if I subtract 1 from both sides, remember we want to get all of the stuff on one side because we have a quadratic. We have secant squared x plus secant x minus 2 equals 0. So now this might be a place where we're going to say, let secant x equal some letter. We'll say u. you can do that u substitution. So this is u squared plus u minus 2 equals 0. And then we'll solve for u. Well, we just did this, didn't we? Probably should have picked a better example. This is going to be u plus 2, u minus 1. So then we get u plus 2 equals 0 and u minus 1 equals 0. We get u equals negative 2 and u equals 1. Or we change the u back to secant and we get secant x equals negative 2 and we get secant x equals 1. Okay, well this time secant x equals negative 2 is not a dead end. This actually is on the unit circle because secant is cosine flipped. And so this would really be, when is the cosine of x equal to negative 1/2? So you flip that fraction, negative 2 would be flipped and it would become negative 1/2. And then same thing here, we'd have cosine x. If we flip 1, 1/1 is still 1. So these are going to be our two answers. All right, so let's look at our unit circle and figure out when does this happen. So here's my unit circle. Let's see if I can draw a decent circle. That was pretty bad. So cosine of x equals negative 1/2. When is the x value? Cosine we look at as the x value. When is that negative 1/2? And so that's going to be right here at 120 or here at 240. Those are the two times when the x value is negative 1/2. The other, so that was part A. For part B here, when is the cosine equal to 1? Well, that's when the x value equals 1, which would just be over here at 0 degrees. So for degrees, our answer are 0, 120, and 240. For radians, it's 0 radians. And this would be, let's see, 2 pi over 3. And 4 pi over 3. All right, this next part is pretty cool. For all real numbers, if you notice, from 0 to 120 is 120 degrees away. From 120 to 240 is 120 degrees away. And from 240 to 0 is also 120 degrees away. So every time you rotate 120 degrees, you land at another new answer. So if we went all the way around to 360 and then went another 120, that's going to be 480. That'll work. And we do another 120, that's 600. That'll work. Do another 120, that's 720. That will also be an answer. So the way we're going to write this is we're going to say it is 0 plus 120n. Or you could just write it as 120n. If you did it in radians, you would write it as, well, 120 is 2 pi over 3, so it would be 2 pi over 3n. How cool is that? So every time you add a multiple of 120, you get an answer. All right, so those are our 3 examples. Just a quick reminder on radians in case you are a little rusty on that. Pi over 6 is 30 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees. Pi over 12, if you notice, is half of pi over 6. So that means that 30 is pi over 6, so that means pi over 12 is going to be 15. So if you know these 4 things, you should be able to get everything around the unit circle that, is a multiple of 15. So 8 pi over 3 is 8 60s. Well, 8 times 60 is 480. What about 11 pi over 12? I didn't need to write that line there. So 11 pi over 12 is 11 15s. Well, 10 15s is 150, so 11 15s would be 165. What about 7 pi over 2? Well, pi over 2 is 90. 7 times 90 is 630. So you just think of how much is one of those. So if it's pi over 12, 1 is 15, and you multiply it by 11, and you get 165. All right, so that is solving trig equations.